What this class basically is pretty much learning about the aerodynamics and the sciences behind building rocketry and flying it. Design the rocket, test it in the simulation, build the rocket, and then make sure we have it ready in time for the actual launch.
It integrates physics, chemistry, and all sorts of facets of science into building and engineering rockets and other devices that help kind of put the science into actual making stuff and actual engineering of objects.
It's about learning engineering through the vehicle of a rocket. We use different iterations of our rockets. In other words, we take a very simple rocket, we make it fly. Sometimes it works, sometimes it doesn't. We learn from what didn't happen correctly, and we apply all the physics that they've learned in prior classes to make it fly better.
Start off basically by doing little experience, like we start off making little paper rockets we launch from launchers, and we upgrade down to making cardboard and C65, which are little small firework type engines in your rockets with fins that we custom made out of wood and whatnot. And we've progressed slowly using design software like Rocks, and we use to design our rockets with, and we've progressed until we finally start to make our spring project, which is a transonic rocket that's going to hit up to 13,000 feet.
Practiced with 3 prior launches, and now they're on their big spring project, which is the entire spring semester, and they will fly it in early May. We have had numerous people come to us to visit with the students, to watch our launches, to identify and look over their drawings, and it's just very interesting when they get outside mentors or outside engineers looking at their data, looking at their simulations to see if what they're building will actually fly.
Well, it was kind of intimidating because we didn't know what to expect from them, because I mean, they're NASA, like big people, and then us high schoolers building rockets, and they gave us advice on how to put everything together and to be organized and to like keep on with the schedule, which is very difficult, but it's mandatory. Like you have to have a schedule and like keep with it and make sure that you're on track for everything.
So they came in and they kind of like judged our progress on our medium-sized rocket, and it was cool because it was their experience and they knew how to critique, and it showed us new lights about how to think about things. But then also they were very polite and they were just very constructive about it. It wasn't they were like trying to make us feel bad about what we did wrong, but they're like, just fix your mistakes and this is how you can improve, and it was a great experience.
Well, it's definitely like satisfying because like you put so much work into it and you calculate all this stuff, and if your calculations are right, then it flies like it's supposed to and everything. It's a really fun class because you get to learn a lot.
It was very new, it was challenging, but it was fun to get my hands on something new and throw myself into it.
Project-based learning is an absolute must for most engineering type people, or people that are going into engineering, because they get to practice putting their science that they've learned and their math that they've learned into application. And it has a purpose, and that purpose drives learning more.
It allowed me to see I really love aerospace engineering, and so I'm planning to go to University of Texas at Arlington for a dual major in mechanical and aerospace engineering.
It showed me really what engineering is and about making stuff, and it's made me even more want to be an engineer than I did before.